Now we've got to try and find, we found this one, right? Now we've got to try and get this line here, this triangle surface into a single line. And we do that by measuring back one folding plane, we measure the depths, right? So let's go back one folding plane and measure the depths. That means we're measuring here, off there, that's A. Oh wait, I gotta add all these projection lines in, don't I? They're all 90 degrees to this. So somewhere along there, this is A, and it's also, oh no it's not. This line is actually here. It's one of our reference things. This is C and X, line C and X, projection C and X, and this is B. Did I do that right? B, C, X, A? Yep, okay. So on A, I'm going to measure back the depth on A. It's about that far. And I'm going to come over here on A, and I'm going to measure back the depth on A. And it's about right there. And I'm going to call this A sub 1. Right? Now I've got to come back and I've got to measure X. And X is about that far back. And it's about that far. Where did my finger go? There. There, right at the end of the line. There, that's X sub 1. And I got to come back and do B, a little bit more than my hand. Oops, do you see what I just did?
Yep.
Wrong line, right? B, a little bit more than my hand. That's B, my hand, plus a little bit. B sub 1, right? C and X are the same point, they should be the same point. Now if I connect these dots, lo and behold, we've got a straight line. Okay? Does that make sense?
Yep.
Now what do we have to do? Just kind of get in the picture. John, are you raising your hand? No. Who else? Who wants to give it a shot?
All those lines that...
You get the measurements from the B1, B2 line?
Well, first we have to create another folding line, right? So now we're working on the surface 1, the auxiliary surface 1. We need to create another folding line. And we create that folding line parallel to this line that we just made, right? So I'll do it over here.
Does the distance between those two lines matter?
Nope, not at all. It could be there, it could be over here, it doesn't matter at all. As long as it's parallel, it's the only rule.
So that line that you just made is still, it is a triangle, but it's a triangle looking on edge. So in the top
Who's
view,
got a triangle? Let me call you a triangle.
so in the other two views, there are triangles looking at them in a way that you're able to see one of the surfaces. And then in that final view, he's looking at it, what we call coplanar. So all those points, those triangular points, are all on edge. And so we're looking at it.
So this is kind of basically what we might have. I'm not quite sure if this is it. We might be looking at it like that, right? Here we might be looking at it like that, right? But here we're looking at it like that. So all 3 points are dead on. We just see it as a line.
It's like a playing card that we just look on edge.
Yep.
You can't see any of the detail.
Right? Everybody got that? Now what this does is it means if we have this as a line, all we have to do is flip it 90 degrees. And if we flip it 90 degrees, we're looking at it in its true size. And that's why this is parallel, right? Because the parallel, when we rotate it, we're always rotating at 90 degrees. 90 degrees about a straight line is going to give us the true size. So let's do that. So we have this line now, and we're going to label it again. So this side is A1 here, and now we're on the A2 side. A2, right? And we need to do our projection lines, and our projection lines are always what? Perpendicular to our folding line. So we do our projection lines here, our projection line there, and our projection line there. This is projection line A. This is projection line X and C, right? X and C, and this is our projection line B.
It's not quite 90 degrees in the drawing, but that's because he's looking at it at a weird angle. So they should be 90.
Does that distance matter? Distance between the line and the
Nope, not at all. Where's my wife? We got this. I think it's Tony looking for Rick. It doesn't scale. It's scale.
I get
This distance is totally irrelevant. As long as they're parallel, it's the only thing they need to be. As long as they're parallel and your projection lines are perpendicular, you're golden.
Yep, I'll send him to get that in about 15 minutes.
Okay, so what we need to do now is we need to go back. We're on this surface now, right? We're on the A1 surface. So to find this depth, we need to measure it by looking at the adjacent depth down. So from this line, we're going to measure back. Let's start at A. We're going to kind of go back about that far, and it's A. I need to go A. I'm measuring from there. So Matt's going to write it again. A is clear back there. This is A sub 2. I'm going to go back B. Go back.
Wrong line.
B.
Wrong line.
It's the right
You-
line.
B.
He needs to measure off the...
B. I measured off of this line right here,
Oh yeah, sorry.
right? And I'm measuring off of this line right there.
No, you didn't. You did it off the black one.
Okay, good call. B. See, I need you guys.
Wesley was watching.
B sub 2, right? C. C sub 2, and we should also have X.
I think I understand it.
X sub 2. Now if we connect all these points, hopefully we get a triangle. And what we should find out is point X is on line AB, 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 especially if I drew it accurately. Right? If that point's out here somewhere in space or in here, you've done something wrong. So you always got kind of a system of checks and balances, right? And now this is its true size, so we actually just label it with a big TS. Oh. Come up here and show me. No, these folding lines, the folding lines can be anywhere. There's no reference of where they have to be. They only have to be parallel or
Your auxiliary ones.
your auxiliary.
The data that you got for that one, so the lines that you drew, is it,
Let me borrow this. I'll see if I can explain.
Because
We are-
the straightforward floating planes have to be
Yeah.
equally distant from the...
So we kind of understand these shapes. We've been working with enough that we